Hi, welcome to a new day. Yesterday we did some regular expression analysis, extracting pieces of strings. Today we're going to be working on more intelligent strings. Working on intelligent strings requires the use of natural processing techniques. In Python, you can do natural language processing using the NLTK library, which we will install and use in the next video. The NLTK library will allow us to treat strings as real text that has meaning. So we can do sentiment analysis, for example, to find the mood of that text. And we can also know if a word is an article or a noun. So natural language processing allows us to do such analysis. So get ready and I'll talk to you in the next videos. See you there. Hey, welcome back. Yesterday we did some analysis such as finding out what the most used words are in the text, and we ended up with this list of tuples. And we realized that articles are the words that are used the most. However, regular expressions, the RE library, doesn't allow us to distinguish if something is an article or it is something else, such as a noun or a verb. And that is why we need NLTK, the natural language processing for Python. So I'll be opening a new Jupyter notebook and start the analysis from scratch. I do recommend you do the same, although you can work on the previous notebook, whatever you prefer. Either way, it's fine. So in this notebook, I want to load the miracle in the end, this text file again. If you don't have this, find it attached in this lecture. So that will give us the book as a string, right? That's the book. Now, so that was loading the book. Now let's find out the most used words, non-articles. Well, to find the most used words which are non-articles, first we need to find the most used words including articles as well, and we already did that somewhere in here. So using that, code there, import RE. So we still need to use regular expressions to make a list of tuples like this. So that's code as well. So place that in another cell. And also we had this. So that should return the findings. Here I'm just printing out the first 5 words. So these are the words. And then those words, we convert them into a dictionary. So if I print out the dictionary here, we will get this. The words along with their occurrences, their counts in the texts in the book. So let me remove that. And then we have this. So let's store the dlist sorted in here. Dlist is this. So with those 3 cells, we were able to construct a list of tuples. Each tuple contains the word and its number of occurrences in the text. Now, let me just display like the first 5 here. Now we need to use the NLTK library. But first you need to install it. To install it in a cell, you should do pip 3.11 or 3.12, whatever Python version you have. Maybe you have 3.10. So you should know what version JupyterLab is using. If you don't know what Python version your Jupyter is using, you can do from platform import python underscore version, and then here do python underscore version, so call that function and that should return the Python version you have, and then do again pip 3.11 whatever version you had, install NLTK. That should install the NLTK library in Jupyter. Then you should import NLTK, and then do from nltk.corpus import stop words, and then inside the variable you want to store the English stop words. For that you need to do stop words.words. Words is a method that will download the English stop words. So execute that. And then you want to check out what English stop words is. So these are things like articles and pronouns, so words which are used very often in English. And this is a list. So now we have that and we have this. Therefore we can cross-check this against this and basically filter out the words of this list so that this contains only the words which are not in this list. Let's do that. So we want to iterate for count words in the list. So the list is this, right, which contains those, and count will represent that number and words will represent those words, that, and that, and so on. And then we say if words not in English stop words, and we want to create a new list. So let's create a new list here. Let's say filtered words is currently empty, but then as we iterate we say filtered words dot append, and we append the word. Actually we append a tuple which contains the words and the count for each occurrence which is not in this list. So if it's not in English stop words, execute that, and then filtered words will be this. So now we see that the word oud is actually the most used ones, then followed by us and said and Roberto. Roberto was the author's best friend, so he mentioned him a lot in the book. And then we have other words. Snow is very used here because in the book things are happening in a mountain covered in snow, and there we have mountain as well, and so on. So that's how you filter out the words, removing stop words. And so that's the first step to introducing natural language processing. So basically this library gives you access to words and their meanings, so to say. So in this case we know that these are stop words, so words which are very commonly used, like and that and etc. In the next videos we're going to be using more examples of natural language processing so that you understand what it is exactly. I'll see you in the next videos. Welcome to this video. In this video we will continue doing natural language processing, and particularly in this video we will do sentiment analysis, and that is finding the mood of a piece of text, if it's positive or negative. So let's see how we can do that. This is the code we wrote so far, And since this output is too long, I'll just print out just the first results of the most used words. And then create a new cell here, make it a markdown cell, and this will be sentiment analysis. What is the most positive and the most negative chapter? To perform sentiment analysis, we need a sentiment intensity analyzer class, which comes from nltk.sentiment import sentiment intensity analyzer. So I'm executing the cell, and in the next one, since we have just imported a class in here, we need to instantiate that class to create an object instance from that class. So sentiment intensity analyzer with parentheses, and that will create an analyzer object instance, which doesn't look any exciting for now, so you don't see any actual user-friendly output. But this object instance now has methods. You can check them with dir, and among them, the one we need is a polarity score method. So .polarity scores, sorry. Yes, polarity scores. Polarity scores now expects a string. This could be one sentence, this could be one paragraph, and this could also be an entire book, but it should be a string. For example, let's say, hey, look how full the trees are. I love them. If you press Ctrl Enter now to execute this, you're going to get a dictionary as output. And these are the so-called polarity scores. We have the negativity, the neutrality, and the positivity, and also a compound coefficient. So let's look at them. Negativity here is 0.0. Obviously, because this is a very positive sentence, so we don't have negativity there. But it can range from 0 to 1. Then we have neutrality. This is 0.464. This can also range from 0 to 1. And then positivity is the highest score. So it's 0.536. Then we have the compound. The compound might range from -1 to 1. And if it's above 0, as it is in this case, if it's above 0, that means that the sentence is more positive than negative. And if it's below 0, it means the sentence, the text is more negative than positive. So let's try to add something else here, such as I really love them. So we're trying to make the sentence even more positive. If I execute that, we saw a slight increase in the positivity coefficient. But if we say, for example, how bad the trees are, I hate them, and I really hate them, then we're going to see that the negativity has increased, positivity is 0, and the compound coefficient is now negative. So in order to find out the mood of a text, you should use these polarity scores, and then perhaps you can write a conditional block such as if, let's store this in a scores variable, this dictionary, and execute that, right? And then you say if scores pos is greater than scores neg, you print out it is a positive text, else print it is a negative text. So basically you can make use of those scores and make the program decide if a text is positive or negative. And of course we can also try now this code on the book. So instead of that string we can provide the entire book variable. Press enter and that should give you the dictionary with the scores. So since this book talks both about a tragedy but also a miracle, we do have a balance here, so the negativity is close to the positivity coefficient. Now let's try to analyze its chapter separately. So this here was just an example, and now we need to analyze chapters sentiment analysis. Right, for that we need the RE library and the pattern, which should be re.compile, and that was chapter 029 plus. So that will help us to split the book by chapters. We did cover regular expressions yesterday, so please go to yesterday's videos if you don't know what I'm doing here. Chapters will be re.split. So the re, the regular expression library, does have a split method which splits a piece of text by a pattern. So it will split the book by this pattern. Wherever this pattern is met, that is where the split point will be on this book. So now chapters will be a list of chapters. However, the very first occurrence here is an empty string, so we need to get rid of that. Because you see the length of chapters is not 10 but it is 11 because of that first string there. So we could say chapters is equal to chapters 1, and so we only extract the chapters starting from the first item, from this very first chapter, excluding that. So execute that. Chapters now is the actual chapters. Right. Now we can say for chapter in chapters scores is equal to that method, and in parentheses we should provide the chapter, right? Each chapter in here, and then print out the scores. So let's try this. And there we go. So we can look at the negativity here. So we can see, for example, that the very first chapter is the less negative of all, actually. And that is because the book talks about a team which was going to play a match somewhere else. And this was like full of harmony between the team players. They had great expectations on the game and so on. So there was no negativity in this chapter. But the positivity is also not the highest one, because you see in this last chapter the positivity was the highest. So this is the last chapter. In the last chapter of the book, the ordeal ended. So there was a lot of positivity and so on. And I suppose that the middle chapters are the most negative one, where the problems were happening in the book and so on. Alright, so that's what you get. Of course, you can take this even further. You can perhaps write some if-else conditionals, or you can even write for number, so the chapter number, chapter in enumerate chapters, and then you can print out the number along the scores. So there you go, chapter number 0, chapter number 1, and so on. Or you can say number plus 1, and you get the correct numbers of the chapters along the sentiment analysis dictionary. So yeah, with that, I thank you for following this, and I'll talk to you in the next videos. See you. Welcome to today's exercise. For this exercise, you have to plot your diary tone. Let me explain what that is. So this will consist of a Streamlit app, and this app will read a series of text files, which you can find attached in the lecture resources. So these are 7 text files. So please take these text files, put them in a folder, and place that folder in your PyCharm project directory. So each of these have some fake diary entries. So someone has written something about their day for this particular day, how their day was, and then there's another entry for another date. Another date, another. So there are 7 of them. So this graph here, what is plotting is the positivity of each day, the positivity coefficient. So 21st of October, 22nd, 23rd, and so on. Same goes for negativity. So this other graph is plotting negativity as a line graph along the date. So date negativity, date positivity, and so these are your files. And if you want to listen to some hints, then please keep listening to this video. Otherwise, you can pause here, or you can stop this video and continue working, and you can come better at this minute to hear about the hints. Right, so some hints. The first hint is you can use the glob library to get a list of these file names. A second hint is to use the sorted function to sort that list, because you might get a list which is not sorted by dates. But if you get the list of file paths and you put that file paths in a sorted function, that would make sure to sort out these file names in the correct order. So these are my 2 hints. Good luck. See you later. Hello. In this video, I'll give you my solution to the diary tone project, where you visualize the moods based on your diary entries. And this is my code. So let me explain you how I did this. I have some import statements in here, and then first of all I created a file paths list. So this will look something like this. So that's a list of file paths, and then I instantiated the sentiment intensity analyzer class. I prepared 2 empty lists, so these will be the place where I will store the negativity and the positivity coefficients. So in order to store those coefficients in these 2 lists, I am looping over the file paths list. So this list that I showed you here. So I'm going to each file, and for each file I'm creating a file object and then reading the content, storing that content in the content variable. Then I will calculate the scores for each content. So in the first loop, I'll get a dictionary with the scores representing the negativity and positivity scores for that first file. That's in the first loop. And so then what I do is I access this list which is currently empty, and I append the positivity score to the positivity list. And I do the same for the negativity list, which is created in here. So in the first iteration, I'll have one value here, one value here. Then in the second iteration, we go through the second file and we will store the second value here and the second value here, and so on and so forth until the seventh file. And we will end up with two lists with 7 items each. Then I'm extracting the dates using this list comprehension. So I'm iterating over file paths for name in file paths. And for each name, basically, this will be the name variables. So for that, for example, I remove the .txt part, this part, and I also remove the diary / part, this part here. You might have done this differently, so don't expect that we have the same code. I usually mention that. So that's where the part of getting the data ends, and then we work on Streamlit. So perhaps you put this in a function, that's great. And so this is the Streamlit part. We create a diary tone title, which corresponds to this. We create a subheader for the first graph and then create a Plotly figure using px, which I imported in here. And so that's the Plotly figure for the first plot. So we're plotting dates in the x-axis and positivity, the list in the y-axis, and we render the charts on the web page, and we do exactly the same with the other plots in here, with the difference that negativity is the list that is plotted against the y-axis here. And that's my solution. And that's about this video. Thanks a lot. Hey, welcome to today's programming concept. Today I'll be talking about applications where natural language processing is used. That will give you a more clear understanding of what NLP, natural language processing, does in the real world. So one example is Google Maps reviews. If a user, for example, posts on Google Map a review which is very negative, it contains hate language, for example, that review will be filtered out by Google Maps and it will not be displayed. So Google Maps would use natural language processing to detect hate language. That's one example of how natural language processing is used. Now, programming language wise, what language is Google Maps using? That could be Python, but other languages also have their own natural language processing libraries. However, Python is very popular for doing natural language processing, so it's very likely that Google Maps are using Python as well. Social media monitoring. That's a lot of posts and comments are being posted all the time, and some of those comments and posts can contain harmful language. So social media platforms such as Twitter or Facebook, they do have their algorithms which detect such language and they monitor it or filter it out as Google Maps do. So to do that, natural language processing is used so that it is able to detect the meaning of words basically and cross-check them with their natural language processing database. We have grammar checkers. For example, if you have something like Grammarly or Ginger, so these grammar checkers, and if you have them on your browser installed as an extension and you are writing an email, then the extension can tell you how optimistic or how hateful your text can be. So for that, these grammar checkers are also using NLP. Email spam filters. email servers such as Gmail and Outlook, they do have their algorithms which check emails that are coming to your inbox, and these algorithms decide whether these emails are spam or genuine emails. There are different factors to decide whether an email is spam or not, and one of these factors is related to sentiment analysis. So it checks on the language of those emails and it adds to the entire coefficient to decide whether the email is spam or not. So these were example more in the sentiment analysis field to detect the mood, the tone of the language used. Then we have other parts of natural language processing. For example, Google search uses NLP to try to understand your intent, what you are searching. For example, you might be searching on Google for how to code a chatbot with Python, and Google will show you websites which include this query, how to code a chatbot in Python, but it will also show you websites which mention how to build a chatbot in Python. So build and code are two synonyms here, having the same meaning. So two words having the same meaning, and Google cross-checks your search terms against NLP databases. So NLP also includes things like synonyms, and that is part of natural language processing. Translators also use NLP. They also try to understand the meaning of your text and not just translating your text literally to the other language, for example, English to Chinese or Japanese. So synonyms, for example, might also play a role here. Chatbots work on intent classification. So you enter a text and the chatbot algorithms tries to guess the intent you have, and it will give you an answer based on that. And for that, chatbots will also use NLP. In the course, we will build chatbots, so stay tuned about that. And so these were a few examples of where NLP is applied in real world. Thank you for following this, and let's go further with more apps in the course. See you later.